I am Anil Kumar, and this is part 3 of Rational Functions Review. In this section, we'll review how to solve rational equations, inequalities, and some word problems. So these are the examples which I'll take one by one. I've written equations on the left side, inequalities on the right side. You can always pause the video, copy them, solve, and then look into my solutions. So let's begin with the very first one, which is x minus 5 over x equals to 4. Now if you have a condition like this, we should take lowest common denominator, which is x, right? So we could do that. We can take lowest common denominator on the left side and begin with, or we can take all the terms to the left side and then start. So either way it can work. So I'll prefer to copy the equation, which is x minus 5 over x equals to 4, and bring 4 to the left side. So what we get here is x minus 5 over x minus 4 equals to 0. Now we'll take the common denominator, x. So which is x here? You have to multiply that with x. You get x squared minus 5, and that becomes minus 4x equals to 0. Now that gives you a quadratic equation in the numerator. Now the idea is to rearrange and factor this equation. So you could write this as x squared minus 4x minus 5 over x equals to 0, right? So these are the steps which you need to follow to write the equation in a form which can be factored, and then you can solve it. So let me rewrite this equation here, and then we'll factor it. So we have x squared minus 4x minus 5 equals to over x equals to 0. Now for this equation to be 0, numerator should be 0, right? Let me also emphasize the point that whenever you get rational equations, you should write restrictions. So the restriction here is that x cannot be equal to 0. Perfect. Now for this to be 0, numerator should be 0, correct? So we say numerator should be 0 equal to 0. That means x squared minus 4x minus 5 equals to 0. You can factor this as x minus 5 times x plus 1. Since sum of minus 5 and 1 will give you minus 4, and product will be minus 5. And now each term can be 0 to solve. So x minus 5 equals to 0 gives you x equals to 5, and x plus 1 equals to 0 will provide the second answer, x equals to minus 1. So we get our answer, which is x equals to 5 and minus 1. Now since both of them are none of them is 0, so this is perfect. You don't even have to check it. So that's fine. So once you are clear about the restrictions, you could go ahead and just get the solution, right? If you want, you can check your solution. But I hope with this simple example, you have understood the steps. So we'll take slightly more complicated questions now. So we have with the equation 2 over x minus 1 equals to 5 over x plus 3. So the idea is bring them together to one side. So we could write this as 2 over x minus 1 minus 5 over x plus 3 equals to 0. Now we'll take common denominator, which is product of these two, right? X minus 1 times x plus 3. 2 gets multiplied with x plus 3, and minus 5 times x minus 1 should be equal to 0. Now as I said, we should write restrictions. X is not equal to 1 and not equal to minus 3. So if we get one of these answers, we should never include them. They are not in our domain, right? So now numerator should be 0. Is that okay? So we'll just bother about the numerator and say, well, 2 times x plus 3 minus 5 times x minus 1 should be equal to 0. Open the bracket and solve. So we get 2x plus 6 minus 5x plus 5 equals to 0. So that is a linear equation. So 2x minus 5x is minus 3x, and 6 plus 5 is 11 equals to 0, and that gives you the solution, correct? So what we can do here is just write down our solution, which is we have 3x equals to 11, or x is equals to 11 over 3. So that becomes the solution. So our answer is x equals to 11 over 3, correct? So let's move on to the last one for the equations. So we'll follow the same strategy as we did last time. However, this time we expect quadratic equation. Bringing the terms together gives us x plus 3 over x minus 1 minus x plus 4 over x minus 2 equals to 0. Now the common denominator will be product of x minus 1 and x minus 2. So we get x plus 3 times x minus 2 minus x plus 4 times x minus 1 equals to 0. Now that really means that denominator cannot be 0. So we'll write restriction x not equal to 1 and 2, right? And the numerator should be 0. So we'll just multiply these and equate to 0. So x times x is x squared minus 2x plus 3x minus 6 minus all this, let me put it in brackets since there is negative here. So we get x squared minus x plus 4x minus 4 equals to 0. For this rational function to be 0, numerator should be 0, correct? So we can simplify this. X squared minus x squared is 0. So we get minus 2. So we can actually, this should be, when we did with x, minus 2x, right? I think there's a mistake here. Good, we found it. So x times x squared and then minus 2x. Minus 2x plus 3x is x. So we get x minus 6. And these x squares cancel. Or we could write like this, x squared minus, let's write. And then we combine these, which is minus 3x after opening the bracket. And then this becomes plus 4 equals to 0. And that gives us x squared cancel. We have minus 3x and minus x and minus 3x, which is minus 4x. The numbers are minus 6 plus 4, which is minus 2, equals to 0. Now, equating it to 0 to solve, we can write this as taking to the other side. So we have, let me rewrite. So we have minus 4x equals to 2. X is equals to 2 over minus 4, which is minus half. So our answer here is x equals to minus half. Do you see how simple it is to solve equations? That simple, is it okay? So that is how you should be doing it. Now let's look into inequalities. Now let me this time begin by writing the restrictions first, which should normally be the case that x cannot be equal to 0. Bring them together. So we have 12 over x plus x minus 8 should be less than 0. Take common denominator, x. 12 plus x squared minus 8x should be less than 0. Rearrange. X squared minus 8x plus 12 over x should be less than 0. Factor. Product of 12, 6 and 2. Okay, so it goes 6 with a negative sign, x with a minus 2 over x less than 0. So we get inequality in terms of factored form, correct? Now I will discuss how to solve such inequalities. So we are looking for intervals where the value of the function, which is on the left side, is less than 0 or negative. So we begin by finding zeros and discontinuities, right? So we begin with finding zeros in numerator and denominator. So the idea is to find zeros. Zeros are at x equals to 6 and at x equals to 2, and that's for the numerator, and denominator 0 is at 0. So these are the three, you can say zeros or zeros of numerator and denominator, right? You'll say vertical asymptote in this particular, that's fine. Okay. So we just put these values and test around these values. Since if a function goes through x-intercept, its sign can change, correct? Even when a function is on the either side of a vertical asymptote, the sign can change. That's the whole idea. All these numbers are positive, so we'll write we'll write zeros. I should say critical numbers, right? So the critical numbers, let me say, they are not really zeros of numerator and denominator. So the critical numbers are 0, 2, and 6 for us. Is it okay? Now for these critical numbers, we will take a test point and analyze all the three factors which we have, correct? So you can actually form a table like this. So that's a good method to do. So we'll take test point in these intervals. So these points give you interval. So we'll take test points. So we are looking for interval from -infinity to 0, and this is from 0 to 2, this is from 2 to 6, and this is from 6 to infinity. Is it okay? We can take -1 here, 1 here, 3 here, and 7, for example. These are my factors. Let me write these factors as x for the first 0, x minus 2 for the next one, and x minus 6 for the third one. If I substitute -1, what do I get? If I substitute -1, I get a negative number. This will give me positive. So we don't really have to evaluate. We are looking for a sign. Here in this case, these will be negative. Those will be positive. All these will be negative. The last one will be positive. Now we are looking for this function. Let me call this function as f of x less than 0. So that means all this combined. 3 negatives will give us negative, 2 negatives will give us a positive, 1 will be negative, and that will be positive. We are looking for interval where f of x is less than 0 or negative, right? So we get our solution, and we write down our answer as the interval is from -infinity to 0, and also from 2 to 6. Does make sense to you? So that is how we can actually solve inequalities. So that's the first example, very simple one, but I hope it is important to understand. You get the point that we need to factor. Once you put the factors, make a table and test your point, correct? So that's how it should be done. Okay. Now, since it was less than, we are not including the zeros. That's important to understand, okay? So let's take up another example, which is slightly more difficult than what we took earlier. But we'll bring them together. So it is 2 over x plus 1 minus 5 over x plus 4, and that should be greater than 0. So let's take a common denominator, which is again product of these two, x plus 1 times x plus 4, and we'll multiply 2 by x plus 4 and minus 5 by x plus 1 greater than 0. Correct? Now let's open the numerator, which is 2x plus 8 minus 5x minus 5 over x plus 1 times x plus 4 should be greater than 0. Let's simplify this. 2x minus 5x is minus 3x. 8 minus 5 is plus 3 over x plus 1 times x plus 4 greater than 0. Now that is almost the factored form which we wanted. So let's write it down in factored form. So I'll take minus 3 outside. So I'll say minus 3 outside and x minus 1, right? Over these two, which is x plus 1 times x plus 4. We want that to be greater than 0. And what is our restriction? Denominator cannot be 0. The x is not equal to minus 1 or minus 4. Perfect. Now the idea is to get all the zeros from numerator. So we have zeros from numerator which are at just 1, right? And for denominator, right? Let me write denominator, which is at minus 1 and minus 4. So we are listing zeros from numerator and denominator, correct? So we have to test around these 3 points. So let me draw 4 lines here. So we have 1, 2, 3 points to test, correct? These 3 points given to us are -4. I'll write -4 here as they come on a number line, kind of that order. Is it okay? So these are the points where the sign can change, right? So we call them critical points or critical numbers. Now we will take test points. The test point in this interval, which is from -infinity to +infinity, could be any point, but -5 is good, -2 is good. 0 is always a good point to take. And what are we testing? These factors. So one of these factors is -3. The other one is x minus 1, and then we have x plus 1, x plus 4. Did you notice why I wrote -3 as a factor? Well, for any value, it is going to be negative. Do you see that? Now, the first factor, x minus 1, if I write -5, these will be negative even for 0, then it becomes positive. So the way I write is a pattern, which you will notice. X plus 1, negative, negative, 0. This now becomes positive for x plus 4. -5 will be negative, but these terms will be positive. Now, if I actually multiply all of them or divide whatever, what do you get? Well, 4 negatives becomes a positive, 3 means negative, positive, and negative. We are looking for something which is greater than 0, so that is our solution. Do you get the idea? So the solution here is, let me write down our answer, is in the interval -infinity to -4, and this interval, which is between plus and -1, and -1 to 1. You get an idea, right? So that is what our solution is. So that is how we could actually solve such questions, correct? As you see in this interval, 0 is a part of interval between -1 and 0. If I substitute 0, what do I get? I get 2 greater than 5 over 4, which is true. So that is kind of another test just to figure out we've done everything right. Now here is a question for you as a test problem. You can actually pause the video, copy the question, answer, and then I'll be there with you to share the solution. Now let's solve this inequality. We have already written in the factored form. In previous cases, we were trying to factor. So we have actually 4 factors. We'll start with the table straight away. So look for zeros in numerator. Zeros in numerator are at x equals to 2 and at x equals to -1. And then let's look for zeros in denominator. They are at x equals to 4 and at x equals to -5. Also, write down restrictions. Restrictions here are that x is not equal to zeros of denominator, which are 4 and -5. Correct? Now, these points are called critical points, right? So we have critical numbers or critical points, or you can say numbers, as all these zeros. So let me write them in order: -5, -1, 2, and 4. Based on these critical numbers, we actually make our table, right? We make our table based on these critical numbers, right? So there are 4 critical numbers. So let me just sketch here. Okay, so I will draw these lines here, or we can just complete it here. 4. Okay, we'll just complete it here. So we have 1, 2, 3, 4, and 1, 5. Correct? Now we'll write all these points right there in order. So this is -5, -1, 2, and 4. Let me rewrite. So we have -5, -1, 2, and 4. These critical numbers divide the interval in -infinity to -5. So 4 numbers, 5 intervals, correct? -5 to -1, -1 to 2, 2 to 4, and 4 to infinity. 5 intervals. In each interval, we are going to take a test point. Test point could be -6, -2, 0, 3, and 5. Does make sense to you? So these are the test points. We'll test for sign for each of our factor. I prefer to write them in order where these belong. So we'll write x plus 5 first. That is linear factor. And then we'll write x plus 1. That is whole square. Write as such, whole square. It's important, right? Then with 2, it is x minus 2. And then with 4, it is x minus 4. Perfect. We have to figure out what sign will they result in. Correct? Now, it is simple to first write down square will always be positive. Let's not make any mistake here. Square means whatever you write, it will make it positive. Correct? Okay, let's do the rest. -6 here will give you a negative. -2, all these will be positive for me. Correct? Now, if I write -6 here, it is negative. -2 will give me -4. 0 will give me negative. And 3 is going to give me positive. 5 will also give me positive. For the last one, this is negative, this is negative, because -4 is negative. 3 will also give me negative, but we'll get positive when I substitute 5 here. Correct? Now, if I multiply all this, that is our function f of x, 3 negatives means a negative, 2 negative means a positive, 2 negative means a positive, 1 negative means a negative, all negatives means a positive. Do you see that? So, we are looking for greater than equal to 0 this time. Greater than equal to 0. Since we have these as the restrictions, 4 and 5, 4 and -5. These are like, what we cannot include these guys. Okay. We are looking for wherever the function is greater than equal to 0, that means positive or 0. Is that okay? Positive or 0. So we can now write down our answer as, look here, from -5 to -1, right? However, -5 is a restriction, so we'll write not including -5, but -1 is not a restriction, so we will include 1. Do you get the idea? That is very critical to understand. The next one here is from -1 to 2. These are not restrictions, so we'll say -1 to 2. Both included. The square brackets means included. The last one here is from 4 to infinity. However, 4 cannot be included as that is a restriction, right? And including infinity can never be included. So that's it. So that is the answer. Do you understand when to include, when not to include, right? So you cannot include these restrictions. So that's kind of very important to understand while solving inequalities for rational functions. So I hope this concept is well taken care of. We'll now move forward and take some word problems, right? Okay. So here is a question for you. It's kind of a review of what all we did so far, including part 1, 2, 3, and this one, right? So the question here is, write an equation to represent a rational function with the following conditions. 3 conditions are given to you. Reciprocal of a quadratic function, asymptotes with equation equals to x equals to -5, x equals to 4 over 3, and y equals to 0. All asymptotes, right? So there are vertical and horizontal asymptotes mixed up. Y is less than 0 means the function is negative whenever x is less than -5 or x is greater than 4 over 3. Take your time, solve the question, and then look into my suggestions. Now let us see how to solve such a question. It says write an equation to represent rational function with following condition. Reciprocal of quadratic function. Do you get an idea, right? So straight away, we have to write a function which is kind of 1 over x minus a times x minus b. Do you get it? That is what we need. Now, it says equation with x equals to asymptotes at these points. So let's try to sketch and write down conditions on a graph, right? Now it says we want asymptotes x equals to minus 5. That means a vertical line, right? That makes it vertical asymptote. So we have x equals to minus 5. The other one is 4 over 3, slightly more than 1. So let's say like this. So that is x equals to 4 over 3. Now it says that y equals to 0. That means this is your horizontal asymptote. So for a reciprocal function, as you know, horizontal asymptote will be y equals to 0. Now it is negative less than 0 whenever x is on the left side of this. So we are looking for negative values here and negative here and positive there, correct? So that means the parabola should open downwards. Does make sense to you? Otherwise it cannot be negative, right? So that negative specifies that the parabola should be kind of like this. Does it make sense to you? Because reciprocal of negative is negative, reciprocal of positive is positive, correct? So that really means that we should have negative on the top since the parabola opens downwards. You could have written negative here also. So that is so simple, right? Once you know this, all the information is given to you, you can write your equation. So now I'll write my equation as minus 1 over x. When I say this is at minus 5, my factor is x plus 5. And when I say this is at 4 over 3 positive, it means my factor is 3x minus 4, correct? That's it. So that is the reciprocal of a quadratic function which is going to satisfy all the conditions, correct? If you want, you can open the brackets and write your answer. That's fine. But I'll leave it here for you. And I hope you understand how simple it is to do such questions. Now let's take a word problem. The word problem here is from a test paper. It says, Kiran and Jasmine are joining Nicole at her parents' cottage for the weekend. The cottage is 150 kilometers away from her neighborhood. Kiran can leave directly after school, but Jasmine will be leaving after band practice an hour and a quarter later. Kim took her time and drove slowly, averaging 20 kilometers per hour, slower than Jasmine. They both arrived there at the same time. At what speed were they traveling? Right. So you can always pause the video, answer this question, distance, speed, time question. So important thing here to remember that this triangle, right? How are distance, speed and time related? So we say distance d, speed and time, right? So speed is distance over time, time is distance over speed. Here we are given difference of time, if you see. Is it okay? We are given difference of time in a way. Since it says that Kim took her time and drove slowly, averaging 20 kilometers per hour than Jasmine, but both arrived at the same time, right? So the situation here is, if I make a table, let me make a table here. It's kind of important if we display the information in a table. Okay, so let me make one more. So we're talking about Kiran and Jasmine joining Nicole and her parents. Distance is fixed, 150 for both of them. Jasmine, same distance. Now, Kiran can leave directly after school, but Jasmine will leave after band practice an hour and a quarter later. That means as far as time is concerned, if Kiran takes time t, then Jasmine takes lesser time, right? It is t minus. Hour and a quarter means, let's write 1 over 4, time in hours, correct? As far as speed is concerned, Kim took her time and drove slowly, averaging 20 kilometers per hour slower than Jasmine. So speed was S for Jasmine. This is S minus 20. Doesn't make sense. So we got all the relations, right? How do we get our equation? Simple. We find time for both and say the difference in time is how much? 1 hour and a quarter later. Do you get the idea? So who takes longer? Kiran takes longer. So we'll do time for Kiran minus time for Jasmine should be 1 over 4. 1 over 4, which is actually 5 over 4. Does make sense to you? Correct? So that is how you can build an equation. So I'm taking my time to show you how we're building up the equation. So time is distance over speed. So in our case, distance is 150. Speed for Kiran is S minus 20. Take away 150 over speed is S, and the difference is 5 over 4. Does make sense to you? Correct? Bring all the terms together, or you can cross multiply, whatever you prefer to do. Now we're looking for a quadratic equation here. So I'll prefer to bring all the terms together. So what we have here is we'll multiply by these factors. So 150 gets multiplied by S minus 150 gets multiplied by S minus 20, correct? And actually I should have multiplied by 4 also. Okay, so what I'll do here now is, okay, I kind of thought I'll do it faster, but it's slower than what I thought. So we'll multiply 5 over 4 by S times S minus 20. Okay. So what you can do is now solve. Of course, I should take 4 on this side. So we'll do like this. Does make sense. 4 times. Is that okay? In fact, to solve it, I could take 150 also out. So I'll take 4 times 150 out, and I'll write S minus S, S minus S, and that becomes plus 20. Does make sense to you? Equals to, and I'll open this bracket, which is 5S square minus 100S. Correct. So I've done a few steps, mixed them up. Okay. Now, as you can see, this 5 can be simplified. We could do it 30. I'll prefer you to solve this equation on your own. I'm doing non-standard methods here now. S minus S is 0. Well, this is very effective though. So it's 120 times 20. So what we get here is 100 S minus S 0. 120 times 20 is equal to S square, and sorry, I should also cancel this 5. So which makes it 20 back, correct? So S square minus 20S. Perfect. Anyway, so what we will do here is you redo all this. So let's write down this equation, which is S square minus 20S, bringing that term this side is minus 240 and the 0 equals to 0. Correct. That's what you get. Well, you can use quadratic equation at this moment, or we are looking for product of 2400 and sum of minus 20. 60 and 40 can work for you. So we could factor this. S minus this bigger number, 60 times S plus 40 equals to 0. So the speed could be either 60 or negative is not valid. Just forget about it. Okay. So we get this correct answer. Do you see that? So S is 60, and therefore the friend Kiran was going on average speed of 40. Do you see that? So we did get the answer either way. So we get 60 for Jasmine and 40 for Kiran. So let me just push this page a bit. So our answer is Kiran went at 40 kilometers per hour, and Jasmine J, let's just put here, 60 kilometers per hour on average. But with this, I hope you understand how to solve word problems, right? I did mess around here, but effectively, if you see, this is a very effective method, right? Anyway, you could solve your way. We did a lot of equations. That's the end of our review section. I'll give you a link for many word problems. We have a playlist with about 25 word problems related to rational functions. Practice those. I hope you enjoyed this journey of understanding rational functions, what they are, how they can be written, how we relate them with the graph, how to sketch a graph, solve word problems, and inequalities. Feel free to post your questions and suggestions. If you like and share my videos, that'll be great. Thanks a lot and all the best.